Hi, my name is David Smith, and I'm going to describe my biggest and best robot that I've built so far. I call him Teknion, and he was built for Trinity College firefighting robot competition. But unfortunately, I never finished it because the contest rules changed faster than I could redesign the robot. So, from the ground up, you can see that I have two Teknion DC servo motors with integral gear head and quadrature encoder on the bottom, one in front and one in back. I have used gears, you can see on the bottom side, to offset the gear motors so that I could put the two wheels on the same axis. While I have this up here, you can also see that red and gray thing is the omnidirectional caster wheel that's used to balance the robot. That's what it rests against while it's sitting level. It also has two bumper switches, one on the front, and that's actually the back, one on the back and one on the front. And these are used to detect collisions with walls and chairs and things like that. The frame, as you can tell, is made out of aluminum, and this black plastic here is expanded PVC foam. And I use this to mount the electronics on the different levels. And on the second level, on the back, you can see that I have two 7.2 volt nickel metal hydride battery packs. These are arranged in series for a total of 14.4 volts that is used to drive the motors. And it's also used to power a surplus laptop switching power supply. And this is used to provide the 5 volts to the logic. Inside, kind of wedged in the middle, is a dual N-channel MOSFET H-bridge. This is of my own design, and it works pretty good. It could be improved, but that's what I built. And I also want to mention that on the same level, here kind of packed in on the front, I've got two of these sonar units. It kind of makes it look like an Edsel, but I've got left sonar and right sonar, and each one of these has a transmit and receive transducer. And then on the third level, I have the what I call the mini RoboMind. It was a 68332 board that I bought from a guy. I didn't design this myself, but it has a Motorola 68332. It also has 512K of RAM, and underneath the 512K RAM is a 512K flash device. It also has connectors for the TPU, time processor unit, serial servo connectors, and a bunch of other things too. On the same level, I've got the Bluetooth module for communicating with the PC. I also have 4 IR range sensors, and these are arranged pointing left and right, and I have them on the front and the back. So not only can I measure the distance to a wall, but I can also measure the angle to the wall. So that way I can tell if I'm about ready to hit a wall within the firefighting maze. On the top, on this scanning head, there's actually a servo here, and you can see it move a little bit. No, maybe not. Let's try that again. There we go. That was entering keystrokes into the wrong program. You can see that it scans back and forth, and there's two sensors within the scanning head. There's a long-range infrared sensor, and then there's also a heat sensor. And we have a spotlight set up over here, and you can see that if I press P, it'll do a scan of everything and I'll try to find the warmest object in here. Sometimes it's the light, sometimes it's the camera person. Also on the top here, I have a 4-line by 20 column character LCD. It may be kind of hard to see it on the video, but it's updating LCD about once per second with distances. There's the sonar sensors. It also has the wall sensors on the side here that we saw on the 3rd level. And then it also calculates the angle to the wall. And if you can see that, like on the right angle, the RA1 it's on the 3rd line all the way to the right. It's like calculating an angle. There it is, about 66. This should be close to 0. And it's about there. And if I go here, that's about -60, -72. So it can calculate the angle to a flat object. It also has 2 push buttons for menu selection, so if I needed to set up a simple menuing structure, then I could select different features within the menu. So let's just go ahead and watch this guy move around. You've seen some of the sensor inputs. I'm going to try to maneuver this robot without driving it off of the table, which may be kind of difficult. And you can see that as I push buttons to start and stop the motion, it doesn't just jerk. And that is because it uses a PID motion software where it uses a trapezoidal trajectory where it will ramp up the speed, maintain that speed, and then ramp that down. And while it is controlling the motion, it also monitors the odometry through the same quadrature encoders that are used for the PID feedback. And let me see if I can just move it forward a little bit here and then stop it. And then back. And then I can turn to the left, turn to the right. And that's about all I'm comfortable doing. I also wanted to mention that the control program for that is using the microC OS2 multitasking kernel from Micrium, and that's using the task events and messages and semaphores, everything you'd expect to find in a multitasking kernel. I've set up tasks for monitoring inputs such as the bumper switches, range sensors, etc. It also has tasks for motor control, generating the trajectories, the trapezoidal trajectory that I mentioned before, maintaining the PID feedback, keeping the motor at the desired speed. And it also has tasks for responding to input from the PC via Bluetooth. So and that's about it. That's my robot project, and maybe one of these days I'll actually get it finished. Thanks for watching.